Hello everyone, welcome back to our channel. Today I'm going to present you the general workflow of how to generate a hyperbolic paraboloid inside of Rhino using Grasshopper. This project was inspired by the Dorton Arena in North Carolina. The first step was to generate a hyperbolic paraboloid surface using Grasshopper Python. You can write this script very easily using ChatGPT and you will get a hyperbolic paraboloid surface. Let me turn off the final result first, and then we can talk about the step implementation. As you can see that the top view of this hyperbolic paraboloid surface is a square. Of course, you can change the magnitude of this surface by changing the input here. However, the Dorton Arena has a circular floor plan, so we want to get that in several steps. The first step is to get a grids that can mimic the suspension system on top of the roof, as you can see right here. So we got a set of grid, and then we generate a circle that indicates the edge of the surface. So we can change the radius of the circle, of course. After that, our goal is to find those sails, which are those squares that's inside of this circle, because we definitely want to project them into the hyperbolic paraboloid surface. Let me hide those first. And then we achieve this goal using this set of tools. We find all the sails or all the squares that's inside of this circle without the necessity of cutting them. And then we used another set of functions or components, find all the partial lines that's inside of this circle. In order to get them, you have to cut them, of course. And then we used the next sets of components to find the intersections between the circle and also the lines. So we find a set of points all over the shape. And then we connect those points to generate the polyline here. So this is what we get. We generate the polylines here. Let me turn off the original circle. And then we projected all those lines, which includes 4 lines, those partial lines, and then the polylines that define the edge of the circle onto the hyperbolic paraboloid surface. Now let's hide everything else, and we can just see this. I can change the general shape, the magnitude, and also the radius of this hyperbolic paraboloid surface. At the same time, I can change the density of the suspension members in between. And then we can use the plugin that I wrote, which is called Skunk, to send all the data into SEP 2000. And all you have to do is simply turn this on. And from here, you can start to get a series of complicated structural analysis on this hyperbolic paraboloid surface using SEP 2000. And as you can see that the top view of this shape is still a circle. Thank you so much for your attention, and I'm looking forward to see you in our next tutorial.